What's up guys, MizzoFrizzo from Pitchfork Academy here, and in this Unreal Engine 5.6 tutorial, I'm going to show you how to boost the FPS of your project and reduce overhead and potential bottlenecking by converting your animation blueprint to be entirely thread safe. Now, if you don't know what that means, basically your character being an actor in the world in your game has to exist on the game thread, and your animation blueprint also using the game thread to access properties from your character, such as its velocity and if it's falling. And especially when you go on to build out your animation blueprint to require more and more data from your characters, such as if you've got enemy AI NPCs, for example, and they're all pulling data from those characters in the game world directly on the game thread. It has more and more potential to create bottlenecks on the game thread and reduce the performance of your game. So this is a pretty big step in optimizing your game, especially if you've got more complex functions running on your animation blueprint. I'm going to show you how to run all of it on the worker thread, so that instead of looking directly at your character, it will make copies of the data it needs when it's safe to do so on the worker thread and reduce that potential overhead. I'll be showing you how to create your own thread safe functions in your animation blueprint, as well as how to make sure that all of your transitions and other nodes in your anim graph have fast path enabled. I'm very excited to bring you this one, guys, because it's something that not a lot of people talk about and it's not too difficult to set up. But just before we get started, guys, I'd like to invite you all to join our free and public Discord server, the Pitchfork Academy. It's a space we've created where you guys can get together and discuss our tutorials, look for help, and mix with other like-minded people. I'll leave the invite link in the description and in the pinned comment, but without further ado, let me show you how to do this. Alrighty guys, now for the purposes of this tutorial, I'm going to be doing this in Project Megasample. If you're not familiar with Project Megasample, a couple of months ago I uploaded a video with links to this sample project, which contains retargeted animations, all of the animations from the Advanced Locomotion System, the Lyra starter game, and the game animation sample project, the motion matching sample project. Now, I'm just doing it in here so I have a couple of animations I can use for the extra states I'm going to add in my animation blueprint, but I am going to be adding the third person template project content. So if you wanted to follow along in the third person template, this will be very easy to follow along with, or you can do it in your own project, because everything, absolutely everything that I'm going to be showing you is applicable to any project. And of course, I'm going to be doing this tutorial in Unreal Engine 5.6. So I've literally just downloaded Project Megasample and opened it up in 5.6. And the next thing I'm going to do is click Add Feature Content or Pack, and add the third person content pack to this project. And the next thing I'm going to do is filter by level and open up level third person, the template level. And I also want to set this as the default map in my project settings. So I'm going to go to Edit, Project Settings, Maps and Modes, and I'm going to change the Editor Startup map to the third person level and the game default map to the third person level. And while we're here in the project settings, I'm going to search for Allow Multi, and you'll see that under Anim Blueprints in the general settings here, we've got Allow Multi-Threaded Animation Update, and this is true by default, but just in case somehow this got switched off in your project, you do want to make sure that Allow Multi-Threaded Animation Update is true in your project settings. The next thing I'm going to do is open up my BP third person character, and I'm also going to select the mesh and browse to the anim class here, the animation blueprint, and open up the animation blueprint. And if we head to the class settings here, you'll see that right here under optimization, use multi-threaded animation update is set to true. So multi-threaded animation update is true by default, at least in the template projects, but you do want to make sure that this is on in the project settings and also here in the class settings of your animation blueprint. And guys, it's also worth mentioning if we head over to the class defaults here and have a look at the root motion mode that's selected by default, root motion from montages is selected here. And I just wanted to touch on the fact that root motion can sort of disable thread safe operations in your animation blueprint because root motion needs to sort of work on the game thread because of the way that it translates your character. It's sort of, changes the location of your character that's driven by the animation. That sort of needs to happen on the game thread, and we're going to be converting the sort of bulk of the animation blueprint to happen on a worker thread by making it thread safe. And the way that I've set this up, it doesn't seem to interfere, but it is just worth mentioning that if you do end up having problems later on while root motion is sort of being enacted, such as in a montage that pushes your character around, or if you're using motion matching or something like that. This is just a caveat that I thought I'd mention sooner rather than later. Now, if we head on over to the event graph, the first thing I want to draw your attention to is this event blueprint update animation. And this basically fires on tick. So all of this stuff here that is updating, that is pulling from your character and your character's movement component to update all of these variables to sort of dictate which animations will play. This is being pulled from your character and sort of read from your character on tick here. So this is fine in a template project where, there's not too much going on here, but once you get more and more advanced functions and you need to pull more and more data from your character, this can cause a bottleneck to sort of run these in sequence because this is firing on the game thread. It's just reading all of this stuff directly from your character, and because your character is an actor, in the world here, it sort of needs to use the game thread to read all of these. So instead, what we're going to do is convert this to be thread safe and sort of get this data on a worker thread. So instead of reading it directly from your character, what it will do is it will make a copy of that data when it is safe to do so that it will not interfere with the game thread. So we're actually going to disconnect this because ideally you'll have basically nothing running on this node right here. And if you look in the Lyra starter game, that's how they've done it. They don't have anything running on here. They've got it all in thread safe functions. So what I'm actually going to do is grab all of this stuff here and press Control C to copy. And then over here under functions, I'm going to click override, and here you'll find blueprint thread safe update animation. We can override this function, and this is basically the thread safe version of this update animation node right here. So this runs on worker threads, and this thread safe functionality that runs on the worker thread is not actually able to directly access data from your actor. It instead, as I said earlier, makes a copy of that data when it is safe to do so. And this greatly reduces overhead and potential bottlenecks of your animation blueprint, especially when you've got more and more advanced operations happening. So if you look at the Lyra starter game, there's quite a lot going on in that project. And, part of the optimization of something with all of the different sort of animation stuff going on, the different layers and aim offsets and all sorts of different stuff going on, is much more optimal to run it on this blueprint thread safe update animation. So we could just, paste all of that stuff from the event graph in here and run it in here, but instead I'm going to show you how to create a thread safe function. So if we just create a new function here and we call it TS for thread safe, update movement data or something like that. I'm going to paste all of that stuff from the main event graph in here, and I'm also going to select the sort of input node here, and over here in the details panel, if you drop down this advanced section, you will find the option to make this function thread safe. But in order to actually make this function work, we will have to change how this data is sort of accessed. So if I plug this in here and I hit compile, we will get an error because, as it says down here, just using the object references that we created sort of on initialize animation is not thread safe. So instead we need to use a property access node. So if I right click here and I just search for ACC for access, you'll see it'll come up with this property access node right here. And these are immensely powerful. If we drop down this binding here, we'll see a bunch of these properties that we can access that are built in to this node. And we'll also see all of our variables down here under properties, which is kind of like accessing the class default. So if there is a variable down here, it will be down here in properties. So if we go to the event graph, we've got these references to the character and the movement component that are created on Blueprint Initialize Animation. And right here, if we drop the binding down, we'll see these same references down here to the character and the movement component. Now, in theory, you could actually delete these references and instead just use try get pawn owner, because you can get pawn owner here, and then you can get a whole bunch of stuff from the character class, and you can even find the movement component here. But I have actually found that some of the things I've looked for in here I've been unable to find. And just for ease of access, I do actually prefer to keep these references to the character and the movement component. And often I find what I'm looking for in here. So we need to replace these object references with property access nodes and access the relevant data in here. So for example, this is pulling the velocity from the movement component. We can drop this down, go to the movement component, and just search for velocity and grab the velocity. And then we just replace these nodes right here with our property access node, and so on and so forth. Anywhere where we need to pull data from the character or the character's movement component, we can just get a property access node, go to the character, and what are we looking for here? Actor rotation. Go to the character, search for rot maybe, and get actor rotation. Replace these like so. Orient rotation to movement. We can right click, find a property access node, go to the movement component, search for orient, and get our B orient rotation to movement. Plug this in here like so. And if we compile now, those errors will go away. But we've got a little bit more code to plug in here, and I'm just going to plug this in series like so. Whoops. And I'll hit compile just to see the errors, just so that we can see clearly, where we have to make these changes. We've got current acceleration here, get a property access node, movement component, and search for our current acceleration. Plug this in here. And is falling as well. Property access, movement component, and is falling. Nice. If we compile now, we've got no errors, so this thread safe function is good to go. We just need to make sure that we call this on our Blueprint thread safe update animation. So we'll drag this out here and call our TS update movement data. And now if we hit play, our character is animated as per usual. Sorry, I'm just getting some startup chugging here. It's an Unreal Engine 5.6 thing. Seems to chug a lot on startup. There we go. It's a little bit better. And that is essentially how you convert that sort of core functionality here of, these core movement variables that are usually set on Event Blueprint Update Animation in the template project into a thread safe function that, as I said, runs on the worker thread sort of in the background and copies that data from your character and your character's movement component when it is safe to do so. And you'll see this is kind of always firing here which is pretty cool. And actually, one more thing I want to mention about these property access nodes is that if you open this up, you can change the call site here. And I probably wouldn't recommend using these. Really, you can just leave it on automatic most of the time. I'm not going to go into these different call sites, but basically, yeah, you're pretty safe to leave this on automatic 99.999% of the time, because it will just, it says here pre-event graph, it will automatically determine what call site to use. So don't worry about that. The next thing I want to show you is how to actually add, if I bring up a fresh property access node here, I'm going to show you how to add functions here. So to sort of build functions into your property access node that will, for example, return, you know, a float for your aim offset or something like that. So in this case, I'm going to create one that returns a rotator that rotates the spine bones of our character. So to do this, I'm first going to just delete this stuff from the main event graph here. And I'm going to plug this back in, and I'm just going to create a little calculation here that calculates a rotator to rotate the spine bones of our character. So I'll get my character reference, and I'll get control rotation. And for anyone that's done you know, any of my weapon system tutorials or my make your first game tutorials, this code is going to be very familiar. But basically, I'm going to take the pitch rotation, so how far up and down I'm looking with my mouse, and I'm going to use that to rotate the spine bones of our character to make her look up and down. So I'm going to grab a subtract node here, hold control and move this here, and do 360 minus the pitch. I'm also going to multiply the pitch by -1, and I'm also going to check if it's greater than 180 degrees, and I'll grab a select float, plug these in here, and basically this is taking the number that this outputs here, and it's converting it into something we can use for a rotator, because if you're looking up past horizontal, this number is totally different to when you're looking down. So we just need to use this to either subtract it from 360 or negate it, and this will give us something that we can use here. I'm also going to divide this by 5 because I'm going to use 5 spine bones here, so I'm just dividing this by 5. And let's make rotator. And then this rotator I'm going to promote to a variable, and I'll just call it pitch. I'll plug this in here. And as I said, this is going to pull this data from the character on tick, but I'm just creating this here to make sure this works, and then I'm going to create a thread-safe function and add it to our property access node. It's actually pretty handy stuff. So I will now head to the enum graph, and I've got a couple of changes I'm going to make here. I'm going to grab main states, and I'm going to cache it. I'll call the cache main states. And I'm also going to disconnect the foot IK here, and I might just put this default slot right here for now. I'll get my main states, use cached pose main states, and I'll actually duplicate this down here. And I'm going to do a layered blend per bone. This is going to filter out the upper body and allow me to blend something onto the upper body, which will be the spine rotation. So I will just add a branch filter here. I will filter from spine underscore 01 and everything below spine 01 on the hierarchy. I'll check mesh space rotation blend and mesh space scale blend. And then down here, I'm going to add the nodes that will rotate my spine. So I'm going to right click and search for mod and get a transform modify bone. And here, the translation, I'll unexpose that as a pin, scale, unexpose scale, and unexpose alpha. And I'll just have this rotation pin, and the rotation mode here I'll change to add to existing. And I'll change the bone to modify to spine 1. Plug this in here, and then I'm going to duplicate it, change this one to spine 2, duplicate it again, change this one to spine 3, duplicate spine 4, and duplicate spine 5. Whoops, spine 5. Plug all of these into one another, and I'll plug this into the blend poses 0 on my layered blend per bone. And lastly, I'll get my pitch rotator, and I'll plug it into the rotation on all of these spine bones. Sorry, I know this isn't strictly related to thread-safe animation blueprints, but this will be a really great example of a function that we can create in the property access node, and then I'll show you how to use it on these nodes here. So just to double check that this works, I'm going to hit play, and when I look down now, my spine will rotate down. If I look up, my spine will rotate up. Nice. Okay, now that that's working, I'm going to head back to the event graph here. And once again, I'm going to disconnect this node here, and I am going to grab all of these calculations right here, and I won't need the set pitch node. I'll just grab all of these nodes right here that do the calculations. I'll hit Control C to copy these, and then I'm going to create a new function, and I'll call it threadsafe underscore calculate pitch rotator. I'll paste this stuff in. And now this function here, we're going to make it thread safe and also pure. So it's going to be thread safe and pure. And we're going to need a return node. I'll add a return node, plug this in here, and I'm going to drag the return value of my make rotator onto the return node. And this actually has to be called return value exactly like this, capital R, capital V with no spaces. We'll leave this called return value. So these can only have one output, and it needs to be called return value. So when that automatically names that output return value, just leave it as is. And the only other thing here is we need to not use this object reference. We need to pull this with our property access node to make sure this is thread safe. So let's grab a property access node, and we'll find our character, and we'll get control rotation. I might just have to type control rotation. And there's one other nifty thing to point out here. So I can get the control rotation, but I can also just directly grab one property of the control rotation. So I'm actually going to need pitch. So I'm just going to grab control rotation pitch, and I can hold control, click and drag these onto here, and delete these nodes. And now if we hit compile, we shouldn't get any errors. Now that this function exists, and it is thread safe and pure and has one output that is called return value, what we can actually do is anywhere in this blueprint now, we can get a property access node. And if we drop this down, you'll see our thread safe pitch, calculate pitch rotator is right here in our property access node. So this function has now been added here and is built in, and we can grab it wherever we like. But I'm not actually going to call this in the event graph. I'm not going to call it anywhere. I'm actually going to go to the enum graph, and if I delete this, and instead of pulling this from this pitch variable, which we can actually delete now, we're not going to use. If we click on one of these nodes and we have a look at the pin option over here in the details panel, we can drop this down, and you'll see that thread safe calculate pitch rotator is right here in the functions. So we can sort of create a binding on the pin to that thread safe calculate pitch rotator like so. And we should actually be able to just select all of these nodes and change the rotation pin to be bound to thread safe calculate pitch rotator, like so. And that should be working. We hit play now, we look up and down, our character still looks up and down, and our animation blueprint is now grabbing that data for the control rotation using the worker thread in the sort of background. Just ignore all of that stutter, the chugging here. It's just the, I've got another instance of the engine open in the background, so that probably doesn't help. Plus I'm recording, so yeah, my GPU might be struggling a little bit. It definitely doesn't have anything to do with any of this stuff. This is most definitely more performant than running everything on this event blueprint update animation. We can delete this stuff now. And the very last thing I want to show you guys and talk about is fast path. If we head to our enum graph now and go into our locomotion state machine and one of these transitional rules, you'll see this little icon here with this lightning bolt, and you'll see it says fast path enabled. This node is not using any blueprint calls to update its data. And that's because this transitional rule is based on this Boolean should move, and should move is being set in our update movement data. Should move is being set right here, and everything that it's pulling to set is either in this blueprint already, as in it's set right here, ground speed, or pulled with a property access node, so accessed in a thread safe manner. So a lot of our transitions will actually already have fast path enabled, but one thing we can do is head to the class settings here, and right here in optimization underneath our use multi-threaded animation update is this checkbox, warn about blueprint usage. And if we hover over that, it says selecting this option will cause the compiler to emit warnings whenever a call into blueprint is made from the animation graph. This can help track down optimizations that need to be made, i.e. things that are not using fast path. So if we check this and we hit compile, we'll get a warning down here, and if we click the result here, it will take us to the transitional rule for our to falling to jump state right here. This one right here is not thread safe. Now, I'm going to show you a way that I've found to make all of your transitions thread safe, because some of the other options I've found online did not work for all of my transitions, and that is why I'm doing this in Project Mega Sample with these animations, because I'm actually going to create a crouching state and a crouch walking state, just to have a couple of extra states and to show you that this works to make pretty much any transition thread safe. So we've got this transition which is in main states, but if we also head to our locomotion state machine, we've got idle and walk run here. And what I'm actually going to do is use some state aliases here to make this a bit cleaner, because I'll show you what this will look like if I didn't use state aliases. So I'm going to add a state here. We'll call this one crouch. We'll add another state, and we'll call this one crouch walk. And basically all of these states would be able to move to and from each other. So we would have a whole lot of transitions here going all over the place and crossing over one another, and then you'll see that you get these transition rules that are very near to each other, and you've got to kind of figure out which one's which. So instead of having all of these states transition to one another like this, I'm just going to use state aliases to make this cleaner. So I'm going to delete all of these. We'll have all of these in a row like this, and then I can add a state alias. I'll call this to crouch, and this one will select, and I'm just going to make it a global alias, which means it can be transitioned to from any other of these states. And now that this is a global alias, I'll just duplicate it 3 times, and I'll rename this one to crouch walk. This one can be to idle, this one can be to walk, run. I'll put a slash in there. And I'll plug these in like so. And instead of containing our transitional rules in here, what I'm actually going to do is sort of dictate them in a thread safe function. And instead in here, I'm just going to have Booleans, just like we saw from idle to walk run and walk run back to idle that just used this should move Boolean. I'm going to create a Boolean for each of these transitions. So let's create a new variable. I'll call it toCrouch rule. And whoops, that should be a capital C. And this will be a Boolean. I'll duplicate this and I'll call this one toCrouch walk rule. I'll duplicate that. I'll call this one toIdle rule. And last but not least, to walk run rule. And I'll go into each of these transitions and just plug in the appropriate Boolean. toCrouch walk, toIdle rule, and to walk run rule. And I just want to double check that all of these have global alias checked, and they do. Nice. So these will be taken now when these Booleans are set to true. And then let's create a function. I'll call it threadsafe underscore update. Whoops. Update transition rules. And in here, in a series, we're just going to set each of these new Booleans. So toCrouch rule, toCrouch walk, toIdle, and toWalk run. And we'll plug all of these in series, and then we'll plug in their conditions. So we'll do toCrouch first, and crouch will actually be, we'll get a property access node. These actually appear at the bottom here for some reason. And we will, we actually need to add the crouching in our character very quickly. So I'm just going to actually duplicate one of these input actions. So I'll double click this one, browse to this one, IA jump. I'll duplicate it. I'll call this IA crouch, and then I'll add IA crouch to IMC default. Add an input here, IA crouch, drop this down, click this, set this to left control. And now that that has been created and added in my third person character's event graph, I'll grab IA crouch and drop this down. On started, I will crouch, and on cancelled or completed, I will uncrouch. And we also just need to head to the character movement component, search for crouch, and we'll check can crouch. And also because the this causes the capsule component to shrink, the camera sort of jumps up and down as you crouch and uncrouch. So the other thing I want to do is select the camera boom and just enable camera lag so it's a little bit smoother. Nice. And now this is built in to Unreal. This actually sets a Boolean called B is crouched. So we'll compile the third person character blueprint, and now we will grab from our character, we'll search for crouch, and we'll grab B is crouched. And this state will be active if we're crouched and we're not moving. So we'll also get should move and a not Boolean. We'll get an and Boolean. Plug this in here and this in here. And actually these two properties here are the main two that we'll use for all of these. So we can actually just duplicate this, and to crouch walk, we will be crouched and should move to true. And we'll duplicate these once more. Idle rule, we will actually be not crouched and not moving. So I'll duplicate the not boolean, plug this in like so. So we are not crouched and not moving. And then to walk run, we are not crouched and we are moving. Nice. And we just need to select this and make sure that this is thread safe. And then we also need to make sure that we're calling it on our blueprint thread safe update animation. So I'll just call my update transition rules like so and hit compile. And we'll have some warnings. These are just about the animations not being placed in the states yet in our state machine, so we need to remember to do that. But this one is a warning about blueprint usage, so we'll head to that one. This is our jump full rule, and this is the only other rule that we need to create. I sort of forgot about this one. So we need another variable here. We'll duplicate this, and we'll call this to jump rule. Plug this in here, and I'll cut this stuff here, Control X, head back to my update transition rules, and paste this down here. We will set our to jump rule, lastly down here, but we just need to make sure that these do not pull from blueprints. It seems to be fine in here, but I actually would prefer to replace this one with a property access node, and we'll get our character, and it's actually the movement component is falling right here, and replace that there, and we'll replace this with the velocity z of our character. So we get one more property access and character, search for velocity, and we'll get the velocity on the z-axis, plug that in there, and that is entirely thread safe now. So we shouldn't get any warnings about blueprint usage, but we have got these warnings about no animations being in these states. So this is a crouch state here. I'm just going to search for the animation that I want to use. I'll search in GASP for crouch. I think it's crouch loop, M neutral crouch idle loop. I'll just open this one up. Yep, that's the one I'm looking for. I might just Control C that name and then search for it here. Plug that in like so and make sure that loop animation is checked. And then crouch walk also has nothing in here. And the one I'm looking for is neutral crouch loop forward. Nice, we'll use that one. Just Control C that name and search for it. And crouch loop F. Plug this in here and make sure loop animation is checked. And that should be it. We should have all of our animations. We can press the left control to crouch, and we can crouch walk. And if we let go, we got run, idle, jump, and the full loop. And that's all working correctly. And if we head into our animation blueprint and we go into all of these transitions, we should see that little lightning bolt there to denote that fast path is enabled. Fast path, fast path, fast path. Very, very nice. And now that you've got that warning checked in the class defaults, anytime that something is trying to use blueprints to access data, it will warn you so that you can, optimize that to use the fast path. And if we head to the enum graph, actually, all of these transform modify bones are also using fast path because we bound that pin to that pure thread safe function that we created. This is cool stuff. You can even use this to pin an alpha. So right here, we've got the alpha of our control rig. We could also create functions, pure thread safe functions with that return value, such as doing your left hand IK or something. You could pull that data from your character in a thread safe manner. And that's going to be it from me today, guys. I was very, very excited to put this tutorial out because it's something that not really many people are talking about. You know, you have to, if you open up the Lyra starter game, it says in there that for this project, they chose to use the Blueprint thread safe update animation. But what they should probably actually be saying is that for any project with a great deal of game thread stuff that the animation blueprint relies on to dictate which animations it's playing and rotating bones, for hand sway and, whatever, it should actually be using blueprint thread safe update animation to reduce the chance of bottlenecks on the game thread, which can be reserved for things that actually happen in your game. So this is a huge, huge step to optimizing your animation blueprint, because as I said, this is basically event tick, and we do not want to, be pulling stuff directly from the character on tick. We actually had someone in the Discord who's making a sort of top-down espionage shooter, and he has tons of enemies, and as the game started to develop with lots and lots of enemies firing at him, the game's frame rate just started to plummet. And this is the kind of thing that you can use to optimize the animation blueprints in your game, especially if you've got lots of AI NPCs, for example, with their own animation blueprints. You don't want all of that stuff interfering with the game thread by pulling directly from the character. As I said, these thread safe functions and these property access nodes actually look at that data and then make a copy of it when it's safe to do so, in order to reduce that overhead of the game thread and reduce the chance of bottlenecks. But once again, guys, it is worth mentioning that your root motion can potentially interfere with your thread safe operations here in your animation blueprint. Now, I haven't actually witnessed it, which is why I've shown you, for example, this kind of setup with all of these thread safe functions and property access nodes. When I tested this, it didn't actually interfere. Root motion did not interfere with my thread safe operations, but it is worth mentioning that if you do see issues, especially when you're using montages, for example, with root motion, if you notice any issues, such as, your character's animation blueprints no longer receiving the velocity or the is falling, or whatever it might be while you're using root motion, then you have some idea why that might be, and you might be able to redesign your animation blueprint accordingly. But that's it, guys. If this video has been of any use or value to you whatsoever, please hit like and subscribe, and I will see you on the next one.